Hello students, so we have solved till question 34. Okay, so let's solve question 35. The perimeter of an isosceles triangle is 200 centimeter. If its base is changing at the rate of 5 centimeter per second, then find a rate at which the altitude is changing when the base is 40 centimeter. Okay, so let's write what is given. So here they have given perimeter of an isosceles triangle. So we have to draw one isosceles triangle. So isosceles means its two sides are equal. So suppose this is A, I'm writing this as also A. Okay, let base of the isosceles triangle be B. Okay, triangle ABC, and this is our altitude, which is height. Okay, so base is I am taking B. So I'll write let base of the triangle be triangle ABC is B, then its altitude H, okay, and the side of the triangle be A. Okay, so its perimeter is given to be 200 centimeter. Perimeter is given 200 centimeter. Okay, then its base is changing at the rate of 5 centimeter per second. So base is changing dB by dt 5 centimeter per second. So we have to find the rate at which the altitude is changing when the base is 40 centimeters. So altitude is h. So dh by dt we have to find when base is given 40 centimeter. Okay. So let's start. So perimeter is given. Perimeter is we have to add all the three sides. So A plus A plus B is our 200 centimeter, right? So this is 2A plus B equal to 200. So from this we can write A 200 minus B upon 2. Okay, now we can find H by using Pythagoras. Okay, so this will be half, this is half. Okay, so using Pythagoras, for triangle ADC. Okay, so it will be A square equal to H square plus B by 2 the whole square. A square, A is given, so A we can substitute. A we have found 200 minus B upon 2 the whole square equal to H square plus B square upon 4. Okay, so I'll take this B square upon 4 this side. So this is 200 minus B the whole square upon 4 plus B square minus B square upon 4. So expanding this will get 4 minus 400B plus b square minus b square upon 4. So this gets cancelled, then we can divide this, so this will be minus 100b. Okay, this is our h square. Okay, now rate of change of h we have to find, right, when b is 40. So derivating this 2h dh by dt equal to, this is 0, this is minus 100 dB by dt. Okay, so dh by dt is minus 100 upon 2h dB by dt. So this is minus 50 upon h dB by dt. Okay, now we have to make use of the information which is given. Okay, so we are given b equal to 40 centimeter. Okay, so if I put this b in here, so I'll get the value of a, right? So a equal to 200 minus 40 upon 2. So this is 100 minus 20, which is 80. Okay, so we have this information, that is when b is 40, a is 80. Okay, when b is 40, a is 80. Okay, so we can make use of this equation, equation 1. So substituting in 1. Okay, this we are doing because we want to find this h. Okay, so a square, 80 square equal to, in this equation, h square plus 40 upon 2 the whole square. Okay, so this will be 20. So we'll get 6400 equal to h square plus 400. So h square is 6400 minus 400, 6000. Okay, so h is root of 6000. So we can write this as 15 for the 100. So 10 and 2 we can take outside. (20 √ 15). Okay, so this is our h. This h you can substitute here in this in the equation. Let's say this is equation 2. So substituting h in equation 2, dh by dt minus 50 upon 20 √ 15 dB by dt is given 5, right? So into 5. So this is minus 25 upon 2 √ 15. It is changing, so centimeter per second. Okay, so this is the rate of change of altitude when our b is 40 centimeter. Next question is OR question. Okay, show that the semi-vertical angle of the cone of maximum volume and of given slant height is cos inverse 1 upon √3. So theta we have to show that it is cos inverse 1 upon √3. Okay, let's start solving this. So cone, first you draw the cone. So this angle is theta, this is slant height L, then perpendicular height is H, radius is R. Okay, triangle A, B, C. This is 90 degree. Okay, so in triangle ABC, I'm using Pythagoras. So it is L square equal to R square plus H square. Okay, so R square is L square minus H square. So if I use trigonometric values ratio, then cos theta is adjacent upon opposite. Adjacent is R, adjacent is H, and adjacent upon hypotenuse. Adjacent is H and hypotenuse is L. Okay, so cos theta is H upon L. Okay, now see volume. Volume is, because it is given, we have to show that the semi-vertical angle of the cone of maximum volume. Okay, so make use of volume equation. So volume of the cone is given by 1/3 pi r square h. Okay, so I am substituting here our r square. So 1/3 pi r square is L square minus H square into H. Okay, so this is 1/3 pi HL square minus H cube. Okay, derivating with respect to height, we'll get pi by 3 L square minus 3H square. Okay, so putting dv by dh equal to 0, we'll get so we are finding the value of height. So this is L square minus 3H square equal to 0. So minus 3H square equal to minus L square. H square is L square upon 3. So H is root of L square upon 3. So this will be L upon root of 3 plus or minus. Okay. Taking the double derivative, d square v by dh square pi by 3 this. So this becomes 0. This is 6h. Okay. 3 2s minus 2 pi h. Okay. Now putting the value of h at this L upon root 3, 2 pi 3. Okay, so this is the okay. So this value comes less than 0. Okay, so volume is maximum when h is L upon root 3. Okay, so now we have to find cos theta. Cos theta is our h upon L. So putting the value of LH, that is L upon root 3. So we'll get 1 upon root 3. So theta is cos inverse 1 upon root 3. Okay.